myself.
So good morning everyone. So this is my implementation for the Shamir sharing. Eh? Okay. So first of all, the goal of Shamir sharing is that once we have okay. Okay. So the goal of
Sorry, can we see the entire screen, right?
Command D.
okay.
And then we are trying
This guy sitting in his spotlight. Is this better?
Yeah. Zoom in a little bit.
You can't see. Can you zoom in a little bit?
This is the good part.
That's the max. Can I do anything on my end?
You can zoom on it.
Yeah? Linux.
Windows B.
Yeah, I've tried increasing it, but
I'm increasing like see my screen. It's better like this. So you can see it. So
we're asking questions. So anything okay.
So the goal of Shaman secret sharing is that we have a secret and want to share it between a certain number of people which we specify. Then we have another condition that if a certain number of people called the threshold come together, they should be able to reproduce that secret. So that's the whole goal. So the major thing that we need to understand is that we just need basically two functions. First of all, the function that is going to help us split the secret, then the function that is going to help us recover the secret. That's just what we need.
Can we hear him?
Yeah.
Can we hear him?
Yeah. Okay, so if everybody is cool with that, so the first thing first, so from the implementation, first of all, we are working with a set of prime fields. The set of prime fields, so we have access to prime numbers and like in the set of final fields. Then the next one we have is the prime polynomial. So this prime polynomial is a library that I have in my code. The major function that I need from there is the interpolation function. So we all know about the interpolation function and why we need the interpolation function. Then the next one that we need is the random, is rand. So rand is going to help me generate random numbers. So that's what rand is going to help me do. So now, okay. Yes, prime. The package that is going to help you get the final field. It's still prime, it's the packages. Prime field. Okay, I'm just saying that it's like I'm calling it prime field.
Is it your?
No, it's not me that. It's not your. It's not my. It's no. The second line. Prime polynomial is made of. Yes. Okay, I'm going to call it. Yes, that's what I'm
Sorry,
Yes. Okay. Sorry. Let me do control first. Yes. Sorry, I created a package called prime polynomial. So you understand? So this is it, prime polynomial. So if you see me, I imported it here. Okay, so this is I imported it here. So let me just show you what.
Prime feels
Right. Prime field. Doesn't necessarily political process. Prime field. Half of the
Yes.
pass. So those things like
But the prime polynomial is your own polynomial multiplication, right?
Yes. Yes. So now this
Everybody
is
understands, like, all of us have our own
Listen to-
implementation of polynomial, right? Yeah. So it's just its own implementation. We brought it into its package. Or into its project. And that continue.
yes. So the prime polynomial is my own implementation of, you know that we did dense polynomial and we did sparse polynomial. So I created a library called prime polynomial. So what it does, I have my function for interpolate. So the goal with Shamir secret sharing is that number one, I have my secrets. So inside my secret now like this, I need to be able to get other random points that if I'm able to complete with the secret, I can be able to like hide my secret inside the process. So now if I come back to this, so if I come back here now, that's why I have, so I have the package here for prime field, then I have my own prime polynomial, then I have this one. This round package is what I'm going to use to be able to generate random coefficients. That's what I'm going to use to generate random coefficients. So first of all, as I said, the major thing that we needed was the split secret and the recover secret. But we have something called create polynomial. So create polynomial is something that is going to help us to be able to hide our secrets. So it's going to help us to hide our secrets. So first of all, if you want to hide a secret, you need a function that's create polynomial that's going to take the secrets and is going to take the degree of that particular secret. Then if you look at it here, I just instantiate the method. So I don't know how to call it in words, but I call it there's run method. The run package helps us to get thread run. Then here we have coefficient. So I'm now initializing a vector. The first position of the vector, if you can check as index 0, I'm putting my secrets there. Are you getting? Sorry, please. At index 0, I'm putting my secret there. Then now see what I'm going to do. For underscore in 0 to degree. So I'm trying to look. The reason why I put underscore there is because I'm not going to use any of the display. I'm not using it actually. What I need is that I want to be able to iterate over from 0 to the degree of the polynomial that we want. Yes, no, not the polynomial, sorry. Not the degree. Then I'm going to do coefficient. So coefficient just push. I think most of us are familiar with JavaScript. We are familiar with JavaScript. So you know that if you have a coefficient outside, if you instantiate a new array outside, I can be able to do the push method on it and be able to add values to it. Yes, not is anybody else?
Any questions?
Any questions so far?
yes.
Any questions?
Okay, so for that random value,
Yeah.
for the random value, what's the type? Is it at that point?
No, it's not yet. It's not yet.
It's
See it here. So when I'm pushing it, when I'm now pushing it, I have to now convert it to a prime field. So when I pass mutable random number, it's going to create for us like a one of the number in the prime fields. That's what is going to push into the array of coefficients. Are you getting? So now if you check at index 0, there's already the secret. Are you getting? So if I'm going to evaluate my polynomial at 0, I'm going to actually get my secret, right? If you check, if I evaluate the polynomial now at 0, I'll be able to get my secret. Then if you check now, here is the prime field. So for each index of random value, I'm actually pushing a new coefficient. So now the next thing to do is that I want to share my secret among the people. So now in order to share my secret, number one, I need the secret that I want to share among the people. Then number two, I need the total number of people. So if it's 10 people that I want to share my secret to, they should come. Then the next one I need is the threshold. The threshold is trying to tell me that how many people needs to come, how many people do I want that if they are able to come together, they should be able to what? Create my what? My secret. Is anybody lost in that part? Yeah. Yes. So now this dense polynomial here, this dense polynomial.
Okay, you're passing your
yes, I'm
instead
passing.
of like passing a threshold.
Here, the dense polynomial. Okay, the degree here.
So that's like your threshold.
No, that's the polynomial that you are able able to complete at that particular point, you should be able to get. Yes. You don't have to threshold. No, your threshold does not have threshold to go around the day. But here,
Eventually, because it's that way.
yes, because of here, at this particular part, see where I'm doing it here. Threshold minus 1.
I
That's
don't
what
need to
it's
go down saying, like, if I want to have a threshold of 4,
Yes.
I need to.
Yes.
Because eventually, will come. I gave it a
Okay, yes.
But they are doing it.
No. I'm doing it here. When I'm creating it, yes.
Okay.
Yes, so I'm doing it there actually. So now the next one is the threshold. So as I said, so the split secret is a function. Is a function that takes 3 parameters. So the secret that you want to split, which is of type F, which is the prime field, it takes a use size or total size of the number of people I want to share my secrets to. Then threshold takes the threshold of the number of people that when they come together, they should be able to create that secret. Right here. So now the next one, first of all, now I'm going to create the polynomial. Remember, I have a function now called create polynomial. So now that create polynomial, remember, it takes only 2 values, the secret and the degree. So now if I have a threshold of 4 people, I need a polynomial of degree 3. That's why you see me, I do threshold minus 1. Are you getting? So now I'm doing threshold minus 1. Then there's what I call all the shares. So all the shares is like all the shares that I'm distributing among, for instance, if it's 10 people, all the shares that I'm going to distribute among all those 10 people. So how do I get all the shares that I give all those 10 people? There's already a function in my library called evaluate. We all know the evaluate function is that if you pass in a particular parameter into the function, it tells you the output. You get. So now that's why number 1, I'm going to instantiate a new array here. That's what is vector. Sorry, I'm mixing array and vectors, but it's vector new. Then I'm going to just look from 1 to the total number of shares. So it's going to go through the remaining 10 people and be able to give each of them. So from the first part now, I'm getting a random value. I'm getting a random value which is f from I as u64. Then the y part, I'm going to evaluate. You know that for every x that I put into the evaluate function, I'm actually going to get a what? A y. Then the next one I'm going to push. I'm going to push x, y coordinates. Remember, it's going to be points in the graph. Are you getting? I'm sharing my secret among 10 people, for instance. And those 10 people now, they need to do okay.
On line 21, you say you're getting a random value. It's really a random value.
It's not really a random value. The value is from I.
1 to
Yes. For number from the prime field now, the prime field is going to generate for us a number from that particular prime field and then return to us as x. Then is that x we are going to use as poly.evaluate and be able to get the y. Then the 2 coordinate points, the point x, y is what we are going to then push into the all shares function. Sorry, all shares array. I don't know if anybody has an issue with that part.
Essentially, like I x is like just I like let's say 0, 1, 2.
Yes.
But don't you think it's predictable?
The thing with the predictability is that I think I asked the question yesterday about that because we know that there's a function from run and be able to pass in the what do they call it, the I. That we know that I can use the random value. So the issue with the random value reason I think he explained is that what if the case whereby the random value that is being generated is like you get 2 of the same number, that there's a possibility now that I get 0. I get it. So that means you're trying to tell me that if I have 0 inside down, I'm going to have another 0, y. I don't know if you get.
So that'll be 2x.
Yes. Like imagine if here now I have something called rand. Here, I get it.
Without passing the eye.
Yeah, without passing the I. Then I can come here now and maybe use the random points here, this random value and then this random value. But the thing is that there's a likelihood that the value that you are getting from here now repeats.
But that's very slow.
The chances are very slow, right?
But this is also not basic.
Yeah.
That's what I'm
It's not like
Yeah.
this.
The fact that the polynomial is random, if nothing makes all the points random. They all know the x, but because they don't know the polynomial, it's random.
I wanted to understand your thought process why you say it's predictable.
like that point of really the index. Or that's like the random polynomial.
So is everybody cool with
Oh,
that?
sorry, even if we, okay, aside that, yes, even if we use the round case, it's still,
It's unlikely, but not zero. Right?
yeah, but it's still secure.
It's probabilistically secure. Yeah.
So which is better to have the X randomized?
This is also secure, so maybe I'll rather go with this.
We are not going to
Yeah. Now, if your X is always zero, for example, and you're doing like this, then there's also a chance that you might get zero, right, on the X. So the person that gets the zero comma something,
Oh, that's the secret. I don't even get. The person that actually gets zero already knows the zero. And remember, we are starting from one. I'm starting from one. The reason being is that in that array that I have from the first part, I've already said that the secret is at what? Zero. I don't even get now. There's the reason why I'm starting from one, because I've already said that at from zero, that's where my secret actually is. So now, moving on. So now, this all shares dot push. Now it means that I've already shared my secrets among the total number of what people, which is the total shares. I've shared all my secrets. Then this total shares is just the threshold of people that if they come together, they should be able to produce that secret. So now the last function that I just need to create is that what, since I've already split my secret now, how do they come back? How do they combine and be able to work? How do those people combine to come and get back what from the secrets? So now, so is everyone with me? Yeah. So now, if we check now, the recover secret will basically just need two things. The recover secret will just need two things. It will just need the people that are trying to come and the people that are trying to come and what do we call it now? To come and form the secret and the threshold. The threshold is not like, it's not by force to actually put the threshold. You understand? The reason why it's not by force to put the threshold is that no matter the amount of people, let's say for instance five people come to create the secret, automatically we know that we just need from the form. If we are going to take an example now, we have if we are going to take an example here in splitting the secrets, we said that let's say for instance we are sharing the total shares among 10 people and we need a threshold of 4 people now. You understand? It means that if 4 people or 5 people come, they should still be able to form that secret. Are you getting? Yeah? If 4 or 5 people come, but anybody, if 2 people come, they will not be able to form that secret. But me, I'm just passing the threshold also here. So the person should be able to pass the people that are coming to look for the secret and the threshold. So now these points this
Quick question.
yeah.
Well, you can still get that by playing shares.
Just next, yes. Yeah, that's what I'm saying. So that's why I said threshold is actually not needed, because I can actually just come and do shares dot length. The amount of people that come is the length that I'm going to use to be able to just get the particular secret. That's what I'm saying. So now the points and shares, if you check it now, I'm just trying to say that I'm not trying to get the number, the threshold. So here, instead of even stressing myself to put just threshold, I would have just put the length, the number of people that came. So now, this is where my dense polynomial actually comes in. So my dense polynomial now is that these people came with their points. Are you getting? Remember, their point is x, y, x, y, x, y, x, y. So I shared it among them, all of them. So now, if all of them come, how do we reconstruct a polynomial? We do reconstruct a polynomial with the help of what? The interpolate function.
I don't understand what's happening on line 29.
Okay.
What is
Like, so, like, I don't understand the syntax, so I don't know what's happening. Why you tell me?
I'm just creating an array actually
From
the shares. I'll spread it.
Like it's trying to
That-
slice its shares.
I
away.
own this
that
Like
Those are good.
let's say,
Wait, so,
let's say like you have your shares now. Let's say you pass like 10 points to your shares,
Yeah.
right? It's trying to limit it to the number of thresholds. Let's say your threshold is 4. You're trying to like interpolate those 4 points. So you're slicing the array just to like make 4 points.
you get yes.
guy-
Yes, sir.
But if you are doing that,
Yes.
that means you won't be able to test points that are larger than your threshold. Meaning that you are limited to only using points that are just your threshold size. Like if
No,
have-
you specify. You know that I said that the recover secret is a number that you actually specify.
Yeah, but even if you like what I'm saying,
Yeah.
from your function now,
Yeah.
your function is taking in shares, like it's taking in all those points,
Yeah.
like an array of 10 tuples
Yeah.
and stuff. But then the threshold is now only bringing out, let's say for a polynomial now, the threshold is only bringing out 3 of them, any 3 of them, or the last 3 of them, and then using it for the interpret. What of can't you have that you can actually use 5 of those or even all 10 of the points?
The reason being what I was thinking while doing this is that I'm trying to just limit my computational power there, because if I'm having, because I know me that created the function, like me that created the package, I know that I only just need 3. So if you like provide me with 10 or 100, I'm just only going to compute 3 of them.
But has that not beating the?
It has not beaten.
Because okay.
So when this line 29, like you said, it slices your array of shares to the number of threshold. Like, what's the starting point? Is it like it just picks from the starting from the first to the when it gets the first threshold? That means you're using including the zeros, like the first guy. I was thinking, if the array is like this, and you know that array contains you're pushing
it does not get the secret form. Yeah, you know that the shares is just points, so I can have 1, 2, 3, 4, like that's the number of points that I'm going to put. This is recover secret form.
Yeah.
You know that I'm going to have to evaluate at point 0.
Okay, scroll up, sorry. Scroll up to where you're creating your shares. The place you're creating your shares.
Yeah.
Okay. All shares. Okay, starting at 1. Okay, makes sense.
Yeah.
But like what I was actually trying to ask is,
Yeah.
you know, at the end of the day we said the point was if we are able to make a quadratic equation from 3 points,
Yeah.
you know, even if you create 10 points from that, even if you pick 10 points from that quadratic curve, you should be able to evaluate back, you should be able to get that polynomial that can evaluate the 0 point and get your secret. But your function is limiting it such that you're only using your threshold. You can't interpolate, like you can't take more than your threshold.
That's why I said is actually what I prefer to do because of the company. I'm just trying to think of, because if I can come here actually now and just remove the threshold. I think that's the argument. I can remove it and just use the length there. You understand? And specify. So if you like,
it's a more solid test to actually check if, given that threshold, you can actually do that stuff down, like keeping it random, like you just keep. But if you keep it to that threshold, you know, like.
Also, if you can test both for your threshold and for length bigger than your threshold. But it only take 3. But it only pick 3. It only use 3.
Exactly. Because he has 1 million. What he has shared is
1 million persons. So you have to look through an array.
Like that's what I'm saying. If you can have a function that we say, okay, I want to use 5 of this, or I want to use 7 of this points. Like, it does not mean that you have to use all 1 million. No. Like you can say, okay, I want to use 5 of these points. No, like not a fixed amount. This is a fixed amount.
no, it's
A variable amount.
look at it.
Look at this.
Yeah. Many people actually wrong because I look at them. Nothing they didn't.
There's no way you can get secret.
Sorry.
There's no way you can get secret. Both can work, it's optional.
Sorry, what I did is actually optional. You can just pass in your shares direct and just use it. But what
That
we
person
are,
in the shares are going to be too large.
yes.
So you know what?
So you get why I limited. You get why I limited it now.
Yes.
You know what is only.
Yeah.
I think we like to
What I'm just saying, like, what I'm just saying is, why are you trying your phone? Okay, please.
Use our food to get it cold.
Yeah, that's what I'm trying to say.
That was.
You can't test for a given number of points. Like say, I want to give 5 points. And I'm not saying test the whole points. No, this one,
No, I can't see. I can't. No.
Understand what chess.
Actually, I can't. Wait, let me answer. I said you can actually test. Okay, when you are passing the recover secret, right? The recover secret. I can test for say I can specify the amount. Sorry.
yeah.
When if you notice when I'm testing, right? When I'm passing the recover secret, I can actually specify how many. If you like, give me 1,000 points. Inside the 1,000 points, I can choose to say I want to only test for 100.
Okay, these shares now. Okay, let's do it like this now. You generated a script for a productive content.
Yes.
Now,
And
now,
it,
we now change that number again now
yes.
to 4, for
Yes.
instance. Like without changing the secret, you know.
Yes, and without changing the threshold and the degree at the top.
Yes. If you change it to 4, then we work.
It will work. It will work.
So this way,
It will work. We'll do it,
you
eh?
know what's that way, they pass it.
We'll do it, eh?
Yeah. No, that is shame.
Just passing the entire share.
So continuing. So now since after
Oh yeah, we want start though.
no as a so now after so please we all understand what I did in 929, right? So now the next one now is that since I've gotten my points that I want to interpolate at, so interpolation means that I have gotten the set of points. I want to now be able to reconstruct my polynomial. Are you getting? So now once I do interpolate at this particular point, it means that I've now gotten the polynomial. So now if I want to be sure that I've gotten the right value, I'm going to have to evaluate the polynomial at what? F0. Remember F0 is where I actually hid my secrets. Are you getting? So F0 is where I hid my secret. So apart from that, that's all actually. So it's just to go test. Eh?
Are you printing out your secret?
You said?
Are you printing out your secret?
At evaluate. No, I'm evaluating. I say evaluate at 0.
So
It
what
will
does it
return the
return?
value, to return the secret.
That is your secret.
Yes. So evaluate at 0 is going to return. So interpolate is going to create a polynomial now.
Why are you doing this?
I want to test it. How do I test it?
Sorry.
Yes.
I think I see now. I think the issue was the fact that you named it threshold.
Okay.
Meaning that
Thinking of this
the other one
notification.
has a threshold and it's fixed. Like I can see the this thing now. Like the point, like I think the issue for me was that you named it threshold. Where the initial threshold is 3. So in my mind I'm just like
Okay, why would I put
No. Yeah, so I
threshold?
think the naming convention was just the naming convention was.
So now, first of all, in my test, right? My test now, I'm going to first test the create polynomial. I just did a simple test actually. I didn't even test the cover. I just did a simple test to test the create polynomial. So I ran the test to test the create polynomial to make sure that if I create the polynomial and I check the coefficients at 0, it should give me my secret. So that's what the test is actually trying to check. So now check. I have a secret. The secret number is 1, 2, 3, 4, 5. U 64. Then the next one is that I'm going to check my create polynomial function. So what my create polynomial function takes in is just a secret and the degree. This name does not matter.
Definitely
This name does not matter.
It's still the same case. It's like brand field.
Yeah. So I wanted to clear that because I know that you mentioned F yesterday.
There's FQ, there's FQ, which is like the greatest test. There's FQ for FQ6, but those are like larger numbers.
But what's the difference between FQ and FR?
And FR, it's a bit of prime. The prime.
So now what I did was that, so I created the polynomial at the secret. I passed in the secret, then I passed the degree, which is 2. Then the next one is that I did assert equals to. My assert equals to is going to check the polynomial coefficients, which is that array. At index 0, it should be equal to my secret. So then the next test that I did was that I tried to take the secret, I split the secret among 5 people. Then I passed a threshold of 3. So since I have 5 people, I'm passing a threshold of 3. So if I have at least 3 people, if they come together, they should be able to come and create my secrets. Then I have the recover secret. So now the recover secret is just going to take the shares, the amount of shares that the people come with. Then I'm now checking how many of those points do I want to test. So I'm checking that I want to test just 3 points inside. So here I can still come and put 300 as far as if you have the 300 points, if you test it for you. So now I'll just run the test.
Command J, yes. Or control.
So if you check that, you see my 2 tests are passing. So just to see if it's actually the secret, I'll come here. Instead of, I want to check if the recover secret now is equal to my main secret here. So I can actually just come here and duplicate this line. Yeah. So in this particular part, I want to actually make it fail.
You're not posting the function.
You
remove the covers.
You said?
The covers. You remove the covers.
No, I want to test this other one, like to make the function.
You're not testing the function.
Okay.
Yeah.
Yeah, the covers. Yeah, I want it to fail actually, so it failed. If you check it now, it failed. Yeah, so that's it.
Okay, so does it make sense? Are we sure? No questions?
Don't answer the questions.
They don't answer the questions. Okay, so like that's
Sorry, I have a question. See that? Like, is it possible for like my secret to be like, I know it is always meant for at the first index. Can it be in the second or third index?
it can be at the 1 million.
Because when he's doing his stuff now, like when he's doing his stuff, I could see that it was the first one to like to generate his own secret polynomial. It was not actually interpolating it. Just get the random points spread it.
Yeah.
You get so now in the case hereby I don't want to put my secret in the first index obviously. In the second one, I want to put it in the second one. With this not like we create polynomial work.
Okay, so that's one of the reasons why we wanted all of you to run, like, to just come up with your ideas and build what you have in your head, right? Everybody's going to have different implementations, right? But the major thing is the idea. The implementation you came up with, does it portray the idea of what you're trying to achieve, right? In that situation now, since maybe let's say in a situation where you want the password to not be 0,
right? You want it to be maybe 5 million. In that case, you can't create your polynomial this way, right? But you can as well still generate a random polynomial with random values and then evaluate that polynomial at your password to get your secret. Eh? Okay, the password part. In this situation, our password is 0 because when we evaluate our polynomial at 0, we get our secret. You can as well decide to choose any other thing for your password. You can decide to use 1,000. You can decide to use 5 million. But the idea is that when you evaluate that polynomial at the password, you should get the secret. Then when you get the secret, you can then assert, right, that if your secret is equal to what you got when you evaluated the polynomial at the password, then it should pass, right? Else it should fail. Does it make sense? Sorry.
So, in the case where, if we are generating the random values, the random coefficients, we generate them randomly, starting from like a particular point. So, in the case where maybe the password that was computed is among the index of that loop of generating the random coefficients. So there's something wisdom said that you can check for that. So if the password is equal to the index of that loop, you can just keep it like continue to the next guy.
Because like one reason why going this route is pretty easy is because we are generating random coefficients, right? Another way we could go about it was generating random x and y values, right? But the thing about that one is that we're now going to, after generating random x and y values, we will need to interpolate to get the polynomial. Interpolation on its own is a costly operation, right? And after interpolating to get the polynomial, we are now still going to evaluate that polynomial at more points, which is kind of like another costly operation, right? And there's also the possibility that after interpolating, let's say we generate 4 random points. They were random, but then after interpolating, we get a polynomial. Normally we would have gotten a polynomial of what degree? 3, right? If we interpolate 4 points, we are expected to get a polynomial of degree 3. But it's still possible that we might have generated those points randomly. But then after interpolating, we get a polynomial of a lower degree, which is like degree 2. So that means that 2 people can regenerate the polynomial. So instead of us having a quadratic, we are having a straight line that 2 people can interpolate. That means our threshold is now 2 instead of 3, which is like a security risk, right? So like different people will have their different approaches or their different ways of going about that. In this case, maybe after interpolating, you need to check the degree of your polynomial. If the degree of your polynomial is like 1 less the threshold, right? Because it's possible for it to have something lesser. If it's lesser, you pick random points again and interpolate, right? Until you have gotten the number of points you need. I don't know if that makes sense. Makes sense, right? Any other question?
You said something about the password to get your secret. Is the password like the hash of something you're trying to find, like the message you're trying to find?
Okay, no. In this case, since we said our secret to be the evaluation of the polynomial at 0, so 0 in this case is our password, right? you can decide to say maybe your password is your name, the hash of your name, right? So you hash your name. When you hash your name, you're going to get a random set of bits, right? If you're using SHA-256, you get a 256 bits long number, right? You can now evaluate that polynomial at that your password, your name hash, right, to get your secret. So it's just about what you want.
Point of putting it instead of inputting it at 0, you know?
Yes.
That's
Yes, at the hash of your name. I don't know if it makes sense. So it's just like, it's still the same Shamir secret sharing protocol, but different, based on your different implementations, you're going to be having like different security risks or like things to consider. The idea is to understand the protocol. Your password is the X. So this now doesn't even have anything to do with hiding, right? It's just normal polynomial evaluation, right? So your password, you can think of your password as the value of X, and then your secret as the value of Y, right? Because when you evaluate your polynomial at X, you're going to get Y. So you use the value of X as your password and the value of Y as your secret. Maybe because I'm using password, the term password, that's why it's confusing, right? What should we use? Key? Key. Okay. So you can use your X value as the key to store your password as a Y value. Does it make sense now? As the Y value. So hide, yes, as the Y value. Does it make sense now? So your X value is the key, and then your Y value is your password. It makes sense now. Any other question?
For sure.
Okay.
In your implementation, when you did shares, this is from Marina, by the way, not my question, it's the woman's question. When you did shares and then sliced the threshold, what if the number of shares are less than the threshold? The number of shares are less than the threshold that I pass. Yes. When you're recovering, when you're trying to recover the secret, and someone, maybe your threshold is 5, and they pass in 3 shares. Okay, very well. They would feel the better.
Are you sure?
So all those ones are things that you can now go back to verify your code. So I think we can take the break, and then when we come back, we'll start with multilinear polynomials. Yo.